This tutorial will show you how to set up and analyze an EDEM simulation. The model we'll use for this tutorial is a rock box conveyor transfer system. First, start by setting the required units for the simulation. Next, define the bulk and equipment materials. For this tutorial we'll use the GEMM material wizard, that is a database of non-calibrated EDEM material models, and it contains the required physics and associated material parameters to start with your EDEM simulation. You have to answer 3 questions about your material to obtain a suitable material model. The wizard will present the 10 closest matches from the EDEM database based on the 3 options previously entered. Select the medium and high wall friction options from the inclination test details section. This will generate 2 different equipment materials. The wizard will have now imported a bulk material and 2 equipment materials. Rename all the materials created. Next, import the CAD file provided and rename the geometry sections. Assign the materials to the equipment. You have to set up the head pulley motion by adding a linear rotation kinematic with the following parameters. Configure the moving conveyors, and add a conveyor translation motion with the following parameters. You can choose to input the directional coordinates or pick the points using the Pick tool. Copy the motion and edit the parameters to give it 2 different kinematics. Next, move on to the feed conveyor and add the conveyor kinematic, and set the motion parameters. Next you have to create a particle factory by adding a polygon geometry and setting the factory type to virtual. Adjust the factory geometry's position to align with the rock box geometry. Next, add a dynamic particle factory, set to generate an unlimited number of particles with a target mass flow rate. Initialize the particles with a velocity to improve particle creation. Save your project and move to the EDEM simulator. Set the time step to 20% of the Rayleigh time step. Enter the simulation time and target save interval. If you're using the CPU solver, make sure to select the correct cell size. Click the Start Progress button to run your simulation. Once the simulation is finished, move to the EDEM analyst to post-process the results. Configure the display settings and reduce the geometry's opacity to see the particles flow clearly. You can configure the particle display to visualize them as individual particles, vectors, streams, and more. Additionally, coloring the geometries by velocity can enhance the visualization of equipment motion. Coloring particles by their velocity helps to better understand the particle flow. Next, to monitor the mass flow over time on the bottom conveyor, add a mass flow sensor. The sensor will track and record the mass flow. To monitor the gradual mass increase in the rock box, a grid bin group can be set up. This will allow for a clear observation of the mass changes over time, and the material data can be exported for analysis. Set a selection query for the bin group, and select particle mass. Set the query type to total. Choose the display options for the bin group. Next, plot the mass flow rate for the bottom conveyor. Choose the mass flow sensor as the selection and plot the mass flow rate of particles. Ensure that time range covers the entire simulation time. The selection can be changed to the bin group you created, and you can plot the total mass in the rock box. From the graph, we can conclude that a steady state has not been reached yet.